Right, so good afternoon everyone, okay. So we will continue our lecture today with a new topic, okay, hypothesis testing, okay. So by this week we will finish this hypothesis testing and then we can focus back on our practical, which is statistical inference, okay. Alright, so this one is the hypothesis testing, okay. So what is important about the hypothesis testing? What is the definition of the hypothesis testing? Where is the hypothesis testing is being applied? Okay, we will see by today, right? Okay, so hypothesis testing is, let me write the definition, okay? The first thing before we proceed with the learning objective, okay? Alright, so the definition of the hypothesis testing is the statistical method, okay? The statistical method that the analysts, okay, use to determine, okay, to identify if there is enough evidence, okay, in the sample data, alright? So by today, students should be able to understand the definition used in the hypothesis testing, okay? You should be able to state the hypothesis, the null hypothesis, and also the alternative hypothesis. Null hypothesis and also the alternative hypothesis, or we can write like this, H1, okay? H null and also the H1. Find the critical value for the Z test, okay? State the 5 steps using the hypothesis testing, okay? Alright, so we test the mean, or we compare the mean by using the hypothesis testing, alright, by using the Z test. And the last one is we are testing or compare the mean, okay, for the T test, and also the last one is the Z test for a proportion, okay. Alright, so this is about the hypothesis testing, okay. So hypothesis testing is the researcher are interested in answer any type of question. For example, we have, is the new teaching technique better than traditional one? Okay, this one is a researcher want to answer this type of question, okay? Is the vaccine can cure the COVID-19 virus? Okay, so this is a question that lead to the hypothesis testing, okay? Based on these two questions, okay, we can apply the hypothesis testing, right? So this type of question can be addressed through the statistical hypothesis testing, okay? Based on these two way of the hypothesis testing, we have the H null and also we have the H alternative, okay? Alright, so, okay, 3 methods used to decide, or we do the decision based on the hypothesis testing is, the first one we have the traditional method, okay? Alright, the second one we have the p-value, the third one we have the confidence interval method, okay? The traditional method is based on the Z test, okay, or the critical value, all right, and also the test statistic. The second one is the p-value, okay, and the third one is the confidence interval method, okay. This is the way we're gonna decide our study, okay. All right, so traditional method, okay, this is hypothesis testing for the traditional method, okay. So this one is a statistical hypothesis, is an assumption about the population parameters, okay, assumption about the population parameter, but then this one can be true or may not be true, okay. All right, so how are we going to make a conclusion based on the population? It is based on the data, okay. So from the data that you collect, okay, From the data that you collect, then you make a generalization about the population. This one sample data, and then this one is a population. Okay, from the sample data that you have, and then you can make a statistical hypothesis, and then make a conclusion about the population. This is what we call as a statistical inference. Okay, so under the hypothesis testing, okay, we have two types of hypothesis. The first one we call it as a null hypothesis, or we symbolize like this, H null. Okay, and then we have another one is a H alternative. Okay, and we can call it as a H1 or HA. Okay, all right. So H null, there is no difference between two parameters. Okay, there is no statistically not significant. Okay, H null always there is no statistically significant between two parameters. Okay, and then H1 or H alternative, it is always there is a difference. Okay, H null, okay, for the hypothesis testing, H null there is no statistically significant difference between two parameters, but then for the H alternative there is a significant difference statistically between two parameters. Okay, so basically for the hypothesis testing, we are always want to test based on these two. Okay, let's say we have the hypothesis testing about the correlation. Okay, so we can write like this. Hypothesis about the correlation H null, there is no significant correlation. Okay, there is no significant correlation or association, okay, between two parameters. Okay, that one is there is a correlation. Okay, so our H null should be no correlation between two variables, and then H alternative will be there is a correlation between two variables. Okay, so we see from the traditional method, okay, because under the hypothesis testing, the first one is we need to write the hypothesis testing about the parameters. The second one, we need to choose and select the appropriate test statistic. The third one is we need to make a decision based on the value that we get from the hypothesis testing. Okay, so the first one is the traditional method. Okay, so traditional method we will compare the critical value. Okay, all right, so basically this is the way we're going to write this hypothesis testing. Okay, so we will go with the example one. Okay, so a psychologist feel that playing soft music during a test will change the result of the test. Okay, they said to you, psychologists feel that playing the soft music during the test will change the result of the test. Okay, all right, the psychologist is not sure, okay, whether the grade will be higher or lower. Not sure either the grade will be higher, but there is a changes in terms of the marks, okay, or the test, in terms of the result. Okay, in the past the average of the score was 73. Okay, in the past the score was 73, state the null and the alternative hypothesis. Okay, so they give you one situation or one scenario. Okay, psychologists, okay, they believe that previously they will give the score was 73, but then he feels that playing soft music will change the result. But then don't know. Either the result will be increased or the result will be decreased. Okay? So for this one, we want to test. Alright? And then we should write our hypothesis testing is like this. Okay? Hypothesis for this situation are H null is equal to mu is equal to 73. Okay? And then H alternative mu is not equal to 73. Okay? Why we consider this one is a mu? Because the hypothesis testing is always to test a parameters. Therefore, we cannot have like this. H null X bar equal to 73. H alternative is a X bar is equal to 73, not equal to. We cannot have like this. Why? Because hypothesis testing are not test for the statistic. This one is referring to the sample, not population. So that is why the correct one is always H null equal to mu 73. H1 is equal to mu are not equal to 73. Okay? Right? So this is what we call as a two-tailed hypothesis test. Okay? This one is what we call as a two-tailed hypothesis test. Alright, so we see the example number 2. Okay, the second situation whereby a chemist invests an additive to increase the life of an automobile battery. Okay, so you see from the first one, invest to increase the life of an automobile battery. The mean lifetime of an automobile battery without the additive is a 36 months. Okay, so state the null and alternative hypothesis. Okay, so there will be hypothesis for this situation is equal to H null, okay, mu is equal to 36, and then H1 is a mu is greater than 36. Why? Because you see that from this statement, they want to increase. Okay, highlight the word increase there. Okay, this word increase. That is why they become more than 36. Okay, if you change the word into the decrease, so that one, the H1 will be, H alternative will be mu is less than 36. Okay, so why we always use this mu? Because they mention the mean lifetime. Okay, so the mean is equal to mu. So that is why our hypothesis testing is based on the mu. Okay, right? Because the mean. Alright, so for this one, we can call this one as a right tail hypothesis test. Okay. Alright, we proceed with the third example. Okay, for the hypothesis testing, a contractor wishes to lower heating bills by using a special type of insulation in houses. Okay, so if the average of the monthly heating bill is a 78, okay, her hypothesis about the heating cost with the use of the insulation are, okay, so there should be H null equal to mu equal to 78. Okay, the first one. And then H alternative is always to lower or to decrease the heating bill. So that is why for this one, the H1 will be mu is less than 78. Okay, alright, so this is called as a left tail. Okay, so basically in our hypothesis testing, there will be two conditions. Okay, so H null will be H null, alright, and then H1. Okay, there will be always two tail if not equal. If not equal, we use the two tail test. Okay, so H alternative also can be greater or less than. This one is fall under the one tail. Okay, there is a difference between these two. Okay, so how are you going to know that one is increase or decrease will be determine the H1. Okay, and then for the first one, they are not know the either this one will be increase or decrease. Okay. Okay, so when a researcher conduct a study, he or she generally looking to evidence to support a claim. All right, so the claim should be stated as an alternative hypothesis or research hypothesis. Okay. She always generally looking for evidence. Okay, looking for evidence to support the claim, and then the claim will be fall under the alternative hypothesis. Okay. Alright, so after stating the hypothesis, what you should do is design the study. Okay, we design the study. Okay, researchers select the correct statistical test. Okay, you need to correctly select the statistical test. We have so many tests in the statistic. Okay, the first one we have the t-test. We also have the z-test. Okay, so you need to check the condition before you use the t-test or you use the z-test. Okay, normally for the t-test we always deal with the small sample size, and then for the z-test we always deal with the more than 30 sample size. Okay, so this is the correct statistical test. Okay, choose an appropriate level of significance. For example, we have alpha equal to 0.05, 0.01, 0.10. Okay, but normally if the question didn't state, you just select the alpha is equal to 0.05 as a level of significance. Okay, alright, so a statistical test use the data obtained from a sample. Okay, a statistical test, either you choose the statistical test Z or T, okay, and then the statistical test we use the data that we obtain from the sample, okay, and then from the sample we make a generalization about the population. Okay, alright, and then from this also we can make a decision, either we want to reject H null or we want to accept the H alternative. Okay, alright, so this one. Okay, the numerical value obtained from a statistical test, we call it as a test value. For example, like we have the z-test, right? Okay, what is the z-test? Divided by sigma s bar, like you see from the previous topic, right? Okay, so the value that you get from this formula, we can call as a what? We can call as a test value. Okay. Alright, so after you get all this value of the test value you get from the statistical test, alright, and then you also have decided the level of significance, then we will see the 4 possible outcomes for the hypothesis testing. Okay, so this one is the H null is true, and then we reject the H null, so you are possible of making type 1 error. And then this one is a H null false, and then you didn't reject the H null, so you are making the type 2 error. Okay. Alright, so this one from this table, okay, we have made an error. Okay, so type 1 error. 2 types of error in the decision making of the hypothesis testing is the type 1 error and also the type 2 error. Okay, so type 1 error is if null hypothesis is true and then it is rejected. Okay, so you made a type 1 error. But if the null hypothesis is false, but then you are still not reject them, okay, this one is a type 2 error. Wrongly select the hypothesis testing based on the decision making. Okay, alright, so this one is based on the type 1 and type 2 error. Okay, for the decision making. Right. This one only. Okay. Alright, so the critical value. Okay, so the critical value or CV, okay, separate the critical region from the non-critical region. Okay, so the critical region is the range of the value and so on. The test value indicate there is a significant difference and that the null hypothesis should not be rejected. Okay, this one is important. The critical rejection or region is the range of the value of the test value that indicates, okay, there is a significant difference, okay, and that the null hypothesis should be rejected. Okay, so we can see from the example after this. Okay. So how to get this critical value for alpha 0.01? How you get this one? Alpha 0.01, how you get this value, class? Is it you can refer from the table? How you get this value? You can refer from the table, Z table or T table and so on. Okay? Alright, so you get this value 0.03 and then this one is a 2.3 and so on. Get the probability here. Okay, this one you can get from the table. Okay, and then after this, when we use R, okay, the R will provide you the critical value. Okay. Alright, so this one is the step for the traditional method. Okay, step for the traditional method for the hypothesis testing. Okay, state the hypothesis and then identify the claim. Okay, state the hypothesis. The first one is you need to state the H null and also you need to identify the claim. Alright, okay, so what is the claim? The H alternative. Okay, and then find the critical value from the statistical table. Okay, the critical value you need to get from the statistical table. Either this one is from the Z test or either this one is from the T test. Okay. Alright, so compute the test value. How to compute the test value? Compute the test value is from the formula. Okay, critical value from the statistical table, but then test value is from the formula. Either this formula is from the Z or either the formula is from the T. Alright, so you make a decision to reject or not to reject the null hypothesis, and then you write the conclusion. Okay, either that one is provide enough conclusion or not. Okay, so we will see the first one. Okay, alright, so the first one is the Z test of hypothesis for the mean, and then the sigma is known. Okay, so this we will use the Z test. Okay, and then the Z test for this one is equal to X bar minus mu divided by sigma and then divided by n. Okay, so actually sigma divided by square root of n is equal to sigma X bar. They are just change the formula here. Okay, alright. Okay, so the test statistic for Z you will refer to this formula. Okay. Alright, so what is Z test? Okay, Z test for the mean is the formula of famous statistical test for a mean of population, testing for the mean of a population. Okay, and then where to use the Z test? Okay, Z test is used when the sample size is more than or equal to T, and then population is normally distributed, and then the sigma is known. Okay, so population is a normally distributed, means that you need to fulfill that the population is come from the normal distribution. How you know that one is come from the normal distribution? You can check from the Shapiro-Wilk test. Shapiro-Wilk test for the normality. Then you can claim that your data are from the normally distributed. Okay. Alright. So the formula is Z is equal to X bar minus mu divided by sigma divided by square root of n. So this one is the test value. Okay, this one is the test value. Okay, so whereby the Z is equal to, this is the sample mean minus with the hypothesized population mean, alright, and then divided by population standard deviation divided by, okay, square root of the sample size of the number of sample. Okay, this is the formula. Alright, so this one is example for the Z test. Alright, because Z test will compare the mean, okay, one or two mean. Alright, a researcher report the average salary of the assistant professor is more than 42,000. Okay, a researcher report that the average salary of assistant professor is more than 52,000. A sample of 30, okay, a sample of 30 assistant professor has a mean salary of 43.260. Okay, at alpha 0.05, okay, test the claim that assistant professor earn more than the 42 per year. Okay, so the standard deviation of the population is equal to 5230. Okay, so test the claim test the claim that the assistant professor more than 42, more than, okay? So there will be one tail or two tail? One only, okay? Average salary of the assistant professor is the mu equal to 42,000, okay? And then a sample of 30, n is equal to 30, okay? And then mean salary is equal to x bar is equal to 43, 260. Okay, and then okay, so what is H null here? What is H null? The average, right? Average is equal to 42,000. H alternative? This is more than. So mu is equal to 42,000. Okay, this will be the hypothesis testing. Alright, so H null is equal to mu 42,000, and then H1 mu is more than 42,000, and then this one will be the one tail hypothesis testing. Okay, find the critical value. How to get the critical value? This one is from the table, Z table. Okay, Z table. This one we see from the Z table, and then you get Z is equal to 1.65, okay, at alpha 0.05. Okay, later during the practical, we will see how to read the critical value from the Z table. Okay, and then we compute the test value. How to compute? Based on this following information that you need to compute the test value. How to compute the test value? This one. Okay, Z will give you the test value. Okay, so Z is equal to x bar minus mu divided by sigma square root of n. So you will get this one, 1.32. The test value is equal to 1.32, and this, the critical value is a 1.65. Okay, so you need to compare from these two, the test value and also the critical value. Okay, so we made a decision, okay, either we want to reject or either we want to fail to reject the H null. Okay, alright, so since the test value is equal to 1.32 is less than the critical value, 1.65, okay, this one is 1.65 from the table, 1.32 is from the calculation, so we fail to reject the H null. Okay, we fail to reject the null hypothesis. Okay, if we fail to reject the null hypothesis, what happened? We didn't have enough evidence that the assistant professor earned more than 42,000. Okay, there is not enough evidence to support the claim that the assistant professor earned more on average than 42 per year. Okay, therefore we just stay with the average mean for the assistant professor is 42,000. Okay, right. So basically in this traditional method, for this one, traditional method, okay, so we need to set our hypothesis testing and choose the appropriate test for this one. For this case, because we see the sample is more than 30, so we select the Z. Okay, we didn't select for T because of what? Because T is only for the small size, of small sample size, below than the T. Okay, so after that we calculate the value of CV, we calculate the value of test value, TV, test value from the formula, and also we calculate the CV from the statistical table. This one table, if the question related to this, okay, table will be provided. No worries, okay? Alright, so we made decision based on these two values. Okay? Alright, so decision is a test value is less than, TV less than CV. So fail to reject. Okay, why? Because the test value is 1.32 are not involved in the critical region. Okay? Unless you get more than critical region, it is. Okay? So this one is 132. The rejection region is a 1.65. Okay? Since this one fail to reject, but if your test value is 170, so it will be rejected. Okay, because it is within the rejection region. Okay. All right. So the second one, how we going to decide for our hypothesis testing is based on the p-value method. Okay, p-value method. Right. So p-value, if p-value is less than alpha, alpha is equal to 0.05, means that this one we will reject the hash null. Okay, if the p-value is greater than alpha, so we do not reject the hash null. Okay, so one example, you can proceed with the three methods. Okay, the first one traditional method, the second one is the p-value and alpha method. Okay, the third one is the confidence interval method. Okay, all right. So this one is the step of the getting the p-value. Okay, step of getting the p-value. Okay, so the first one, we always have to find and state the hypothesis testing. Okay, and then identify the claim and so on. And the second one, we need to compare the test value, all right, and then we find the p-value. Okay, make the decision, either you will reject the hash null or not reject. And then this one is a conclusion. Okay, all right, so this one is example. Okay, a researcher wished to test the claim that the average cost of tuition and fee at 4-year public college, okay, is greater than 5700, greater than 5700. So, for sure, this one fall under the one-tail test. Okay, all right. So she select a random sample of 30 seats. Okay, you see the sample is 30 seats. All right, and find the mean to be 5950. Okay, the population standard deviation is a 659 there, all right, and then is there evidence to support the claim at 0.05? Okay, for this one, they need you to decide based on the p-value. Okay, they need you to decide either this one will be rejected or we fail to reject the hash null based on the p-value. Okay. All right, so the first one, for the hypothesis testing, you need to always, okay, check for the and write for the hypothesis. Okay, the first one you should be hash null is equal to 5700, and then alternative will be h1 is more than 5700. So you will get the test value. Okay, you will get the test value is equal to 2.28. Okay, 2.28. All right, and then you need to use the p-value. Okay, because this one you need to decide based on the p-value, whereby p-value less than alpha, you need to reject hash null. Okay, if p-value is more than alpha, you are failed to reject the hash null. Okay, all right. So for this p-value, all right, so you need to find the area of z. Okay, is equal to 2.28, and the area is a 9887. Okay, so for this one you will get the p-value is equal to 0.0113. Okay, right. So later we will study how to get the p-value during the practical class. Okay, all right. So our decision is based on the p-value. Okay, so since this one the alpha is equal to 0.05. Okay, if they mention the standardized one is a 0.05, okay, and the p-value is a 0.01. Okay, so p-value here is less than alpha, 0.0013. Okay, alpha is a 0.005. Okay, so our condition is if the p-value is less than alpha, so we reject the hash null. Okay, we reject the hash null. Alright, okay, so this one we reject the hash null, and then we can conclude there is enough evidence to support the claim that the tuition and fees at 4-year public college are greater than 5700. Okay. Alright, okay. The last one, hypothesis testing. Okay, hypothesis testing, but then this one is based on the confidence interval method. Okay, so the last choice to make a decision. Okay, so for this condition, for the confidence interval, okay, when the null hypothesis is rejected, we reject the null hypothesis. Okay, the confidence interval for the mean using the same level of significance will not contain the hypothesized mean. Okay, but when the null hypothesis is not rejected, means that the hypothesized mean will be in the confidence interval. Okay, so we will see this one. Example for this one. Sugar is packed in the 5-pound bags and so on, okay? And inspectors suspect the bag may not contain 5 pounds and so on, okay? So a sample of 50 produce a mean of 4.6 pounds and then a standard deviation is 0.7 and so on, okay? Alright. So is there enough evidence to conclude that the bags do not contain 5 pounds or as stated as a alpha 0.05, okay? Either this one contain or not contain this one, okay? So this is rely on the two-tailed test, okay? All right. So we need to use this one, okay? All right. So H null is equal to 5, and then H alternative mu is not equal to 5, okay? This one will be the two-tailed test, okay? Alpha is equal to 0.05, okay? So the critical value will be 1.95. Right? So this one is from the table. Okay? This one is from the table. Z is equal to S bar and so on. This one is the test value. Okay? So the test value is equal to negative 4.04. Okay? So since the value of negative 4.04 is less than negative 1.96, okay, we reject the null hypothesis. Okay? We reject the null hypothesis. Okay, and then there is enough evidence to conclude that the bag do not weigh for the 5 pounds. Okay. All right, but they ask you to do the 95 confidence interval of the true mean. Okay, so 95 of the interval will be like this. Okay, you need to use this formula of the confidence interval. The highlighted one is the formula in the interval, confidence interval. Okay. So we have the mu and then greater than x bar minus z alpha over 2 sigma divided by square root of n. Okay. So you see the left one, x bar minus z alpha over 2, okay, sigma over n. So that one is a mu. So you just remember one-sided only. The rest you will change the sign. This one is minus. On the right, you will plus. Okay, the one is we call it as a confidence interval. Alright, so when you use this formula and then you get the mu is equal to 4.4 and then this one is a 4.8. Okay, and then your hypothesized mean is equal to 5. They are not included or they are not lie within this confidence interval. So that is why we need to reject. Okay, confidence interval where we get is a 4.4 and then also 4.8, but then the mu is here 5, so they are not within this one. So if the hypothesized mean are not lies within this one, so we need to reject the H null. Okay, if this one, let's say the mean is a 3.5, so 4.48 something, okay, it lies within the confidence interval, so we don't need to reject or we fail to reject the H null. Okay. Alright, so this one we finish for the Z test. Okay. So basically for the hypothesis testing we want to check either we have the enough evidence or not to prove our claim. Okay. We already have the data, but then we proceed with the new claim and then we want to find the evidence. So how we going to get the evidence? Verify is from the sample data that we collected. Okay. The first one after you see the question is you need to identify and write the hypothesis testing. Okay. Alright, and then based on the sample data, number of sample size, either the characteristic and all the data that you have, you need to you need to choose correctly the statistical test. Okay, one example actually you can use for the traditional method. The second one you can use for the p-value also, and the third one is the confidence interval to make a decision either the claim that you provide is true or not. Okay, enough evidence or not. Okay, make a decision based on the three things. Okay, the first traditional method, the second one is the p-value, the third one is based on the confidence interval. Okay, all right, so we will continue this one. Okay, we will finish this one first, all right. So next week we can do the practical together with the t-test, z-test, and also the ANOVA. Because we cannot proceed with the practical without you know the theoretical part first. Okay, so this week we complete the hypothesis testing, and then you proceed with the sampling distribution for the tutorial. Okay, next week we will do the practical. Any question related to the lab assessment? Okay, let me ask here. Right, okay. So that's all class for today. Take your attendance, all right? You may leave, and I will see you tomorrow during the practical and also the tutorial. Okay? This one is automatic. I think this one is automatically right. Can you tell my boss? Okay, yes, any questions?
Just for what we're expected to happen in the video.
Yes?
So for descriptive, we will use something like summary.
Summary.
Summary data.
Okay. Alright, and then what else?
The issues I can't find 3 issues. Most of
Why?
Because the data set from, like, let's say Kaggle, they are pretty clean. I can find, let's say